from Kourou, Centre spatial guyanais. This is the
The Amazon rainforest and the most advanced technology brought together in the same place. This is surely one of the most astonishing features of Kourou and its Arianespace Center. Kourou is the spaceport of Europe. It's one of the most modern launch complexes in the world, and it's ideally located near the equator. This is going to be a direct broadcast, and you're welcomed here by the European Space Agency and the French National Space Agency. Kourou has long been associated with the name of Ariane, but the time has come perhaps to grow accustomed to a change in the number. It's from this Jupiter center that for the first time we will be able to see Ariane 5 on her launch pad. A new launcher requires new facilities. These now extend over 2,000 hectares, but we'll be coming back to that later. It is indeed a great moment. It's a premiere. It is the initial launch of a brand new version of Ariane that we'll be witnessing here with Ariane 501, 5 because that's the name of the new version, 01 because this will be the first launch. But back now to the Jupiter building, because it will be here from the Jupiter Center that together with you and our guests, we will be witnessing this landmark event in the history of the European space industry. It is here in this control center behind the glass that all the data is being regrouped, and it's here that all the decisions are taken with regard to the phase that precedes liftoff. To make this live broadcast possible, and it's being beamed out simultaneously in English and French to both Europe and America, the services of no less than 6 satellites are being used, and in fact some of these were indeed launched by Ariane. After a lengthy preparation period, Ariane 5 is going to conduct its first mission in less than an hour's time. This is the beginning of the launch window. The launch window is the period during which the launch can take place. The beginning of the slot and its duration depend on the constraints of the satellite mission as well as the launcher constraints. H0 is at 8:35 local time. In other words, 8:35 or 13:35 in Darmstadt or in Paris. And we'll be having a satellite link with ISOC very soon. The slot will last 2 hours today on the 4th of June 1996. So it's from 8:35 to 10:35 local time. For this first launch, it was decided to have a daytime launch in order to ensure very good visibility and to be able to monitor the performance of the launcher on the first 60 kilometers. And now we're going to turn to our 2 guests who represent the French National Space Agency and the European Space Agency. Jean-Marie Luton, you're Director General of ESA. Welcome to the CSG.
Bon, d'abord, je voudrais exprimer ma First of all, I would like to express my great satisfaction to be here in Kourou today at the Jupiter Control Center. And I'd like to greet all those who here in Kourou and in Paris are going to follow launch operations. I would like to greet particularly Mr. Ivan Iliev, who is Minister for Scientific Affairs and who is Chairman of the Council of Ministers of the European Space Agency. Everywhere and in Europe, particularly, thousands of people are going to follow this great event during the video broadcast. In Paris, in the various facilities of the European Space Agency and the French National Space Agency, among the industries who participate in the development of Ariane. I'd like to welcome all those who, as I, will witness this great event, although we might be slightly tense at this moment, but it's the culmination point of more than 10 years of continuous efforts. The mission to develop Ariane and to put in orbit cluster satellites, which will teach us about the interactions of the Earth and the Sun. I would like to join my friend Jean-Marie Luton to welcome everybody who is listening to us. I would like to tell everybody that we're here at the Guyana Space Center. The Guyana Space Center will be introduced to you by the director, Mr. Michel Mignot, later on, but I'd like to thank the Guyana Space Center for the remarkable organization we are benefiting from. And I'd like to remind you that the French National Space Agency plays an important role in this program as we are a main contractor. I would also thank the Director of Launchers, the director, Mr. Daniel Meunier, who plays a fundamental role in the implementation of this program, and it's a very great day.
Thank you, Alain Bensusson. We're indeed about to discover Guyana, which is a French département located in the northeast of Latin America. And with some shots provided by the local tourist office, well, we're going to go off on an excursion.
Exigez consommer local, il n'y a pas de problème, consommer local et buvez frais et bien fraîche. C'est-à-dire buvez une glace au sirop des fruits du pays, donc les fruits de notre très chère Guyane. Pays du soleil, bien ensoleillé, Guyane, terre spatiale.
Michel Mignot, as you see, this is a land of adventure, but it's also the space venture. It's the alliance of tradition and modernity.
Of course. First of all, I also would like to welcome you to the Guyana Space Center, the European Spaceport, for this great event, the first launch of Ariane 501. As you have said before, we're here in Guyana, where space activities take place. We are very happy to be here in Guyana in this beautiful French department in Amazon territory in Latin America. The space activities have transformed the image of this region, giving it not only its traditional image, but also, due to the riches, a technological activities for the future. Now, technology rhymes with Ariane. Here, space activities represent 50% of the economy of the department, 30% of jobs, and that's quite considerable. With Guyana, we hope that activities besides space activities develop more and more. Tourist activity, of course, but also activities for industries who can benefit from this wonderful place, who can benefit from this alliance between Latin America.
Everything is going well as far as the operations go.
At the very moment, at T minus 50 minutes, operations are nominal, as we say in our jargon. And we have some worries, however, about the weather conditions, but we'll have a weather report at H minus 30 minutes, and then we will decide whether we have to wait a bit to see some blue sky to launch under wonderful conditions. We will hear this in a few moments from now, and whether we have a slight delay or not. But as far as launcher operations are concerned, the first stage is being filled up. The launch range is nominal. Everything is nominal.
Thank you, Michel Mignot. During this broadcast that's going to last 2 hours, we're going to go to several places. In a few minutes, we're going to go somewhere else here in Kourou, and then after that, we'll go to Paris. But for the moment, we're going to Germany, to ESOC. Pete Smulders.
Yes, I'm Pete Smulders at the European Space Operations Center in Darmstadt, where the European satellites are being monitored. Let us briefly switch to Mike McKay in the main control room. Mike, how are things at the moment?
Thank you, Pete. This is the Mission Control Center in Germany, in Darmstadt, and here we have the A team on shift. They've taken over from the B team, who's preparing the whole control center. So far, everything looks good, and as you heard earlier, this is the nerve center of the mission control. As you can see on the screen, we have the full flight control team on position. This is only part of our team. The rest of the team, who's an industrial support team, are sitting in the next room to provide us expertise in the event of something unforeseen happening. And also we have flight dynamics, who will be calculating all the orbits and producing the maneuver commands that will take the 4 spacecraft into their elliptical orbit. So I've heard on the voice loops that so far everything is green. The status looks good. I've seen also on the board just above me here that all the greens for the ground segment show that everything is in order. And I must admit, the atmosphere here for such a large event is, how should I say, excited and well tempered with the professionalism that has brought Europe to the stand that it is in the space business today. So I think we go back to Kourou at this point, to Martin Ranson.
Yes, thank you very much. The situation here, we have a cloudy, overcast sky. Just to situate things geographically, we're about 10 kilometers from the technical center. A technical center, Philippe, as you know, where all the buildings have the names of the planets of our solar system. All the viewing sites outside around the spaceport bear the names of birds. The most famous of the birds in French Guiana is the toucan, with its large, outsized yellow beak. And our viewing site of Toucan is perhaps one of the most privileged positions. It has a magnificent panoramic view. We have in front of us the final assembly building where Ariane was until yesterday morning. Slightly to the left, we have the launch pad with our launcher surrounded by the 4 lightning masts. Again to the left, nearer to us, we have the vehicle integration building, and then just behind to the left we have the service gantry and the umbilical tower of the Ariane 4 launch pad, and hidden behind the gantry there is an Ariane ready to lift off in a few days' time. Some 350 people have come from Europe and from other parts of the world to participate in this event. About 100 of them are assembled here with us at the Toucan site, but there are also the people who are at the other sites, those sites with those bird names of Kikiwi, Colibri, Agami. People at Carapa as well are all awaiting this event with much anxiety, perhaps, and anticipation. The weather situation is going to be a primary consideration, and as I said, the sky is still overcast, and we're hoping and crossing our fingers that there will be some clearings during this 2-hour window.
Well, we too are making the same wish in Jupiter here to follow this broadcast that's going to last for a little bit less than 2 hours. We have two technical consultants. We have, first of all, Juan de Dalmo from the Launcher Directorate of ESA, and who on several occasions was range operations manager. And now we have Pierre Marx, Quality Director at CNES, and who's always been a member of the team working on Ariane 5 from the beginning. With you, Juan, we're going to discuss something that's very important that Martin Ransom already touched upon briefly, and that is this idea of a Meteo green signal, status signal. It's as if you had a number of keys and you have to open them.
It's a nice way to present it. In fact, we are right now quite a few hundred people participating at this moment to the countdown, certainly more than 500 people. And the status of the systems they are monitoring is summarized in this panel. We could try to describe it from top to bottom. First of all, authorization to launch is given by the operations manager here in Jupiter and his team. Secondly, the launch complex, about 14 kilometers from here, is monitored by a team in the launch center in the blockhouse over there, and they are sending us green right now. Thirdly, the launcher itself certainly has to be also go for liftoff in 44 minutes now. Next is the spacecraft, the 4 cluster spacecraft being monitored by the team, partly here in Jupiter Mission Control, partly closer to the launcher, and of course in Germany, which monitors all the network of stations around the world. They are all green, as you can see. Meteo comes next, weather forecast, and we'll have the occasion of coming back to this. And last but not least, the status of the launch base or launch range, which includes teams located in different sites as well and monitoring logistics. This stands for energy and air conditioning distribution, flight safety, telemetry, tracking, and telecommunication links. And we will try to describe each of these systems later.
Marx, you were a member of the original team working on the Ariane 5 project. What's your impression, and what's the impression of your team when you see it ready to lift off in 43 minutes and 30 seconds?
Well, this is the culmination point of 10 to 15 years of work. I had the honor and privilege to start the first considerations of the design of the launch vehicle. When the first Arianes had been launched, we were already thinking about the future launchers. The economic and industrial issues involved with space became confirmed, and we had to look into the future. And the future is today now. So this is why the first Ariane family, which led to Ariane 4, gave us a stimulus to design a totally new launch vehicle. This new designed vehicle will fly today.
Now I propose we discover together a film sequence that will show us the inside of Ariane 5.
Ariane 5 is based on a quite different design concept to the earlier versions of the launcher. Overall responsibility for the program lies with the European Space Agency ESA, with the French Space Agency CNES performing executive management functions. Aerospatiale is acting as industrial architect. The power needed to get Ariane 5 off the ground is delivered by 2 large solid boosters, and these in fact impart the bulk of acceleration during the first 2 minutes of flight. Thrust is also provided by the Vulcain engine, a single new generation cryogenic propulsion unit. The Vulcain engine, its flight control system, and its tanks make up the cryogenic main stage. Lastly, the upper stage places the payload in the required orbit. The stage is housed in the vehicle equipment bay, which can be regarded as the launcher's brain. The satellites are accommodated in the Speltra multiple satellite carrier structure and in the fairing, whose diameter is substantially greater than in the case of Ariane 4. The design of Ariane 5 makes it suitable for all types of mission.
Can you tell us what the reasons were and what the objectives were when the specifications were set out for Ariane 5?
The specifications were decided, as Mr. Luton mentioned earlier, the ministerial conference of the European Space Agency. Two important conferences took place back in 1985 and 87, where it was decided to start with the development of this new generation of launchers in Europe. This Ariane 5 launches had at that time and still have today the following drivers. First of all, to assure continuity of access to space for Europe and for the rest of the world. Secondly, to have a more performant launcher to adapt it to the increasing mass and volume of satellites. Then to have a more reliable launcher, and I hope Pierre can tell us more about why it is more reliable. At the same time, a less costly launcher, and also to be compatible with manned flights.
What were the technology choices that allowed you to attain these objectives?
Well, first of all, we took into account these three imperatives that Juan has just mentioned. We established the specifications for the launch vehicle to launch twice 3 tons into geostationary orbit, to have a reliability of over 0.98% and a simpler system than Ariane 4. To do this, we chose the following. To lift off and to get out of the atmosphere as quickly as possible, we chose the high thrust that solid propellant boosters allow for. And these two lateral boosters provide for this thrust. To arrive at the velocity that is necessary for the payload to get into orbit, that's done by the central cryogenic stage and the Vulcan engine. This engine is ignited on ground, and it is checked out before the boosters are ignited. Thus, the reliability of the launch vehicle is increased. In order to place the payloads in orbit, we have a small storable propellant stage, which allows Ariane to place satellites in geostationary transfer orbit.
We're now going to discover something that will give us an insight into the operation of the main cryogenic stage, the EPC.
The cryogenic main stage is manufactured by Arianespace. Its tank is made up of cylindrical sections and has a diameter of 5.4 meters, equivalent to that of an Airbus A300 fuselage. The tank structure has been optimized, a particular feature being a common bulkhead separating the oxygen and hydrogen compartments. The tank is produced by the Reuploaded company, a joint subsidiary of Arianespace and Air Liquide. The Vulcan engine, developed by SEP, is the core of the entire launcher. Following a large number of tests on 2 stands, one located in France and the other in Germany, the engine has now gone into series production. From the time of the first tests through to qualification of the complete launcher in French Guiana, Vulcan engines have clocked up total running time on the ground of over 87,000 seconds, equivalent to more than 150 engine flights. Thanks to the decision to test the stage on the actual launch site in Kourou, it was possible to qualify the main stage and the associated ground facilities at one and the same time.
Let's now discover the solid booster stage, the two boosters that are fixed laterally onto the main cryogenic stage.
The boosters contain the largest solid rocket motors ever built by European industry. The boosters are assembled and filled in Guyana by Europropulsion, a joint subsidiary of BPD and SEP. Each booster is made up of 3 segments measuring 3 meters across. The 2 larger segments are loaded in a purpose-built propellant plant in Guyana. The forward segment, the smallest of the 3, is loaded with propellant in Italy. And in Guyana, the igniter is fitted to the top of the booster. To qualify the boosters, 7 test firings were performed on a dedicated test stand in Guyana.
Last of the 4 engines is the storable propellant stage.
The upper stage, developed by Daimler-Benz Aerospace, is the only stage to be ignited in flight. It's powered by storable propellants, some 10 tons of oxidizer and fuel being carried in 4 tanks. Thrust is supplied by a reignitable engine which operates for about 20 minutes. The engine has come through a large number of static tests in Germany.
The launcher needs a brain. That's what we call the equipment bay, and we'll now discover the equipment bay.
The ring-shaped vehicle equipment bay encircles the upper stage. Developed by Matra Marconi Space, the vehicle equipment bay houses much of the launcher's electronics, including the guidance system, onboard computers, and the launch command circuits.
The last 2 components are the spelter and the fairing right at the top of Ariane 5.
To enable several satellites to be launched in the course of a single mission, a special structure known as the Speltra has been developed by Daimler-Benz Aerospace. The lower payload is encapsulated in the Speltra, the upper payload being installed inside the fairing without any special support structure. The fairing, developed by Oerlikon Contraves, protects the payload during flight through the atmosphere. Jettisoning of the 2 half shells that make up the fairing has been tested in a vacuum chamber in the United States.
Start.
Jean Grenier, you're Director General of Eutelsat. Between Eutelsat and Ariane, there's a long history because there have been at least 14 contracts placed by Eutelsat for an Ariane launch.
Yes, this is quite true. Quite personally speaking, I must say that I'm following this event with great emotion. 20 years ago, the French government asked me to convince Intelsat to buy the first 2 Arianes. I wasn't terribly convinced at the time. 20 years later, I was very impressed. Today, I'm customer, and if you want to know what a customer thinks, well, the point of view of a customer is very simple. You have 3 elements that interest us. Availability, that is, the possibility to launch when you need to launch. The cost, and reliability. Ariane 5, from the point of view of availability, for us, has a great advantage. We have spacecraft that weigh 3 tons, the instrumentation, and the joy of finding a partner ought to be easier for us. There is no doubt that reliability theoretically is perfect, and we trust the development team. And as far as costs are concerned, we have spoken of 10% cheaper. We have 4 contracts today with Arianespace. Arianespace are going to choose whether it's an Ariane 4 or an Ariane 5 we travel on. What's the advantage if it's an Ariane 5? Well, there are 2 of them. One, we will be saving the insurance cost for the launch vehicle because of the high reliability. If there is a failure, Arianespace replaces the launch vehicle. And secondly, for the same price, we can certainly achieve a longer lifetime as we can take on more fuel on board. Thank you.
Thank you, Jean Grenier. We're back to Martin Ransom, who has a guest with him.
Yes, and another kind of guest, totally different kind of guest. As you said, the main objective of Ariane is automatic missions for satellites, but there are also astronauts involved. One of those astronauts is with me, Jean-Pierre Aigneret. Jean-Pierre, you are well known for your Altair mission in the summer of 1993.
Before we speak of Ariane, I'd like to put you a question. Were you able to see Kourou, the European spaceport, from orbit? Of course, that's a reflex of a pilot to look at the landing sites and the starting sites from space. And obviously, from up there, it's a privilege to look down to Kourou. You see the Amazon, you see the spaceport, and you see that something magic is happening down there. Is it true that most astronauts are particularly concerned with the development of any new launcher, considering they may need it to get into space? Yes, of course. I joined CNES in 1985 when the Ariane 5 program had just been decided, and I have particular emotion when I see high technology concentrated in such a small volume. Manned spaceflight, which was envisaged right from the outset with this launch vehicle, must take into account a number of aspects. We must also find a compromise between the vehicle and the launch vehicle, and this is a vehicle I was particularly interested in. The manned spaceflight is not so far away then, is it? When we consider that the second qualification flight 502 is not so far away. That's how we can put it, yes. 502 will not be a manned spaceflight, but there is an element on it that can let us judge of the maturity of the European space program. The day we have not only a technological payload under the fairing, but also human beings, a human crew, then we will have reached a full maturity. We'll come back to you after liftoff, but perhaps we can put a last question. When you're on a launch pad, such as this one, does that remind you of your departure from Baikonur? It's quite something different. It's either being on the scene or in the audience. It's an important event for myself. I'm very moved. I've been working on this project with many of my friends. It's a project of utmost importance. It's a human project, and it has enormous importance for Europe.
Thank you very much indeed, Jean-Pierre Aigneret. We'll be meeting later on.
The European Space Agency is one of the two institutions implementing this project for European launcher, and with Frederick Engström, we'll be discussing the role of ESA.
The European Space Agency has 14 member states, and almost all of these member states participate in the financing of the Ariane launcher family. The latest version of Ariane is the Ariane 5, and it's also by far the biggest development in space that Europe has ever done. The European Space Agency is a development organization responsible for the overall development of the Ariane 5 program. The technical execution of the program is delegated to the French space agency CNES, and finally the commercialization of the launcher, selling it to customers all over the world, is given to Arianespace, a private company. The Ariane family of launchers guarantees Europe's free access to space. And in fact, it has also been Ariane that created the so-called commercial launch market, the possibility for anyone to buy a launcher and send up a satellite.
Given the substantial commitment of France to this program, it's the CNES, the French Space Agency, that has industrial responsibility.
The French National Space Agency devised the project, defined the architecture of the launch vehicle, chose the industries, and also defined the contribution of various European countries participating in this program. For Ariane 5, we have new dimensions. For one, in previous program, we were building on what already existed. Ariane 5 is completely new. We created everything, taking into account the volume of the program. This responsibility was considerable. It represented sometimes half of the budget of the European Space Agency. The budget was managed by CNES. This also meant for France a considerable contribution in respect with the total budget of the agency.
Francis Avanzi, you're Director General of Arianespace. After the second qualification flight, 502, it will be up to Arianespace to take over the operations of Ariane 5. Are you ready for the transition?
Of course, we're ready. You know that the teams are joint teams between ESA and CNES, and we are ready to take over the exploitation of this beautiful vehicle and to win the race for Europe. We mustn't forget that Arianespace has more than 50% of the civilian launcher market. Is Ariane 5 the tool you absolutely need? Is it adapted to the market? First of all, we must define the market. I would tend to define 8 criteria, but Mr. Grenier has already quoted 3 of them. Obviously, the mass of the satellites, mass of spacecraft are increasing. The volume of spacecraft, Ariane 5 can propose 130% more than Ariane 4 volume, which allows you to save on the size of the spacecraft, antennas, etc. We also ask for more capacity. You know that 70 satellites are to be placed in orbit by 99, and Ariane 5 will be produced at a rate of 8 per year from 2000 on. Reliability, Mr. Grenier mentioned this. Now, flexibility. Mr. Grenier mentioned the need for availability. Obviously, the operators, the customers, want to have their spacecraft in orbit, in operation, as soon as possible after their order. We have accepted a challenge accepted by European industry to reduce manufacturing cycles by 50%, 24 months rather than 46. As far as services go, we will ensure the continuity of service. It will be guaranteed with the Ariane 4 backup during the transition phase. Will be guaranteed also by possibilities of booking right now over and beyond the year 2000. As far as the evolution is concerned, it's up to us to adapt the product to the needs of the market. To do this, Ariane 5 will be more than a simple launch vehicle. It's going to be a family in itself, allowing for Europe to access space independently, but it will also allow Arianespace and Europe to remain the leaders on the market with more than 50%.
Thank you. And we're back to our 2 technical consultants to have a summary of the situation.
Sur le critère de visibilité de la trajectoire lanceur jusqu'à la séparation des accélérateurs à poudre. À tous de l'EDO, le décompte s'arrêtera automatiquement à H-7 minutes.
Yes, one could have expected this, and in fact, the night has been quite cloudy here in Kourou. We had rain last night, and it is right now raining on Devil's Island, where a special telescope that has recently been installed to track the launchers cannot send us the pictures we were expecting. Its cover had to be closed again because of the rain. So as the range operations manager just announced, we continue countdown until -7 minutes. On the other systems, perhaps I could say quickly that the telemetry checks. The launcher is already sending the telemetry it will be sending during flight, and as many as 5 channels have been checked and are being recorded in the telemetry station close to Jupiter. This is quite specific configuration because instead of one telemetry channel, Ariane 5 for this first flight is sending 5 channels right now from the 2 boosters, from the main stage, and also from the vehicle equipment bay. The Kourou telemetry station receives this data and also the data from the downrange stations. We will come back to that.
Mike McKay, what's happening at ESOC?
Okay, we're back in the main control room. I have here with me Gustav Mecke, who is the project coordinator here at ESOC, and he's also been involved in discussing with the team in Kourou what's been going on. Gus, how's it been going at Kourou?
I must say excellent. Everything went according to the plans. The teams worked in collaboration together, the people from industry and our own people from ESA, from ESTEC. And everything is green on the spacecraft. It's perfect, everything is nominal. So I'm very happy and very pleased.
You're not only in coordination with the people in Kourou, but you also have an industrial team here supporting you. How is they handling the countdown?
That's right. We have also for the support of the ESOC operations now and for the first couple of weeks after launch, industrial people and people from ESTEC here. We have had training sessions, lots of training sessions with ESOC. Everything is very well prepared. Everything is running very, very smoothly. We are therefore going, and let's keep the fingers crossed.
Great. Okay, we go back over to Juan in Jupiter 2.
Martin Ransom, from where you are, you can see a few clouds, I would imagine.
Yes, in fact, the situation is pretty bleak, but we did have a situation that was similar yesterday, where during the launch window between 8:35 and 10:35, there was considerable rain and an overcast sky. But as I understand it, towards the end of that window, there was a very, very short clearing, which would have enabled us to allow a liftoff. So I think one can keep a certain amount of cautious optimism, but at the present time, the sky is pretty cloudy and it doesn't look too optimistic.
The arrangements devised by the French space agency CNES for transporting to Kourou the various launcher components supplied by some 150 firms from 12 different European countries are necessarily complex. The main stage was transported up the Seine from Les Mureaux to Le Havre, where it was loaded on the Toucan. At this point, the upper stage had already been loaded in Bremen and the fairing and Speltra in Rotterdam. At each port of call, the various elements making up the complete launcher thus took their places in the hold and on the bridge of the Toucan, the only exception being the boosters, which are assembled in Kourou. From Pariacabo, the port of arrival in Kourou, the launcher parts were transported to the Guyana Space Center. This marked the beginning of the launch campaign. In the course of the campaign, the cryogenic main stage is erected in the launcher integration building and then positioned over the launch table. The vehicle equipment bay is mounted on the upper stage. The storable propellant stage is installed on the vehicle equipment bay. The assembly is then attached to the 2 boosters following their transfer from the booster integration building and placement on the launch table. Once mechanical assembly has been completed, the various electrical and fluid connections between the stages and with the launch table are established and tested. The launcher countdown rehearsal for Flight 501 took place on the 24th of April. This involved transferring Ariane 5 to the launch zone for a trial run of the different countdown phases. The launcher was then transported back to the final assembly building, where the satellite campaign was by then drawing to a close. The next steps in the assembly sequence were for the speltra containing 2 of the cluster satellites, the 2 other satellites, and finally the fairing to be fitted to the launcher. At this point, Ariane 5 was ready to be launched, all that remained being for it to be transferred to the launch zone.
Let's remind you that the upper stage was filled in the assembly building. We have Mr. Pierre Perez with us here. You are a member of CNES and you have supervised this campaign. It was a rather lengthy campaign. It started in February, if I recall correctly. During a long campaign, a lot of incidents can happen, but that's normal for a first campaign. Yes, this was a development campaign for Ariane 501. As far as verifications go, the normal checks are all carried out, but for this very first campaign, we tested the equipment under extreme conditions, and we made sure that under extreme conditions, the performance required of the launch vehicle for flight were nonetheless guaranteed. Hence, the checks lasted longer than they should. We furthermore carried out a launcher systems rehearsal. This rehearsal corresponds to a dress rehearsal of the launch countdown. It was absolutely necessary to do this in order to validate the procedures and the software in a configuration as close as possible to the launch countdown. So this is why this campaign was a rather lengthy one. We needed 83 working days for this countdown. Do you have the ambition to do things better for the second flight? Yes, for 502, we intend to have a campaign of 50 working days. And after that, the operational teams consider that after 10 launches, we will be able to find a figure of 22 days for the launch campaign. Thank you, Mr. Pierre Perez. The marking event during yesterday's day was this beautiful view of the launch vehicle being rolled out of the assembly building. 500 tons moved slowly towards the launch pad. Let us look at the pictures, and this happened yesterday morning. Ariane 5 is a program that includes 12 countries. A lot of experience was gained in the space industry, not only for launch vehicles, but also spacecraft. We learned how to work together to bring different cultures together so that this becomes a dialogue. Today, the development work, verification of the compatibility of the launch vehicle with the spacecraft has been carried out. All tests were carried out. All files were completed. And we are extremely confident in the success of the launch vehicle. Obviously, there will always be improvements necessary, but the main job is done. Every day is a new adventure in the preparation of this campaign. But to see the launch vehicle out and moving towards the launch zone is really extraordinary. It's the climax of a long waiting period. We hardly dare to believe it all.
And some 10, 11 minutes to count down with that hold that has been announced for the -7 mark. The weather situation still hasn't improved here in French Guiana. Perhaps you have more details at the Jupiter Mission Control.
And what about the weather? No additional information, as Martin Ransom was supposing?
Unfortunately, not. We can perhaps recall what this weather criteria are to authorize liftoff. First of all, the wind has to be slower than 10 meters per second, which is 36 kilometers an hour during flight. Of course, the launcher, as long as it stands on the launch pad, is protected by different systems, a deflecting tower and also a wind damper. Second criteria is the risk of lightning during flight, and several sensors are installed to measure the electric fields. During the waiting phase of the launcher on the ground, it is protected from the lightning by these 4 tall towers. And last, the visibility of the first part of the trajectory has to be cleared and guaranteed so that the telescope on Devil's Island can track up to about 90 kilometers distance from here, where the separation of the 2 solid boosters takes place, and this is a specific requirement of this first launch.
Pierre, qu'est-ce qui se passe côté lanceur?
What's happening on the launcher?
The launch vehicle is ready. It's ready for the automatic sequence at -7 minutes. Unfortunately, the weather conditions prevent us from continuing the countdown. For the moment, what we can say that is that the launch vehicle is filled with liquid hydrogen and liquid oxygen, 155 tons. We're also pre-chilling the engine, and you will see the hydrogen coming out of the nozzle. This hydrogen is used to chill down the pipes and the valves to these conditions. During this time, the launch vehicle is filled from the ground.
So what do we see here? We have an impression that these are flames.
What is happening here is it's called
je confirme qu'il y aura un arrêt des comptes à moins 7 minutes pour raison météo, critère C2 rouge, suivi d'un rouge cluster qui a besoin de 4 minutes avant la reprise du décompte pour programmer son séquenceur de vol.
Donc Pierre, on revient après cette annonce importante du
after hearing that important announcement of the Range Operations Manager, let's come back to the screen for a moment.
Donc c'est Ariane 5 sur sa zone
This
de lancement
is
prête.
Ariane 5, ready on its launch pad.
Là, nous voyons effectivement ce que je disais tout à l'heure.
What we see here is what I mentioned earlier. The hydrogen is being burnt in what we call the hydrogen pool. It's burnt in order to avoid explosive strata.
Yes, perhaps a little explanation on what the Range Operations Manager just said on the paging here. He mentioned the C2 criteria being red, and this corresponds to what we were telling about lightning risk in altitude. The C2 criteria is has to respect a minimum of electric field that is being measured, and this is also not respected. So in fact, this Meteo red status is double.
À tous de l'EDO, arrêt des comptes, tous les moyens sont en configuration, H-7 minutes, rouge météo critère C2, rouge cluster pour programmation du séquenceur de vol.
On the explanation we've just heard from the range operations manager, I think would require some additional information. Can you expand?
We were saying the meteor red is double because of lack of visibility and because of risk of lightning in altitude. To this is now added a non-readiness by the cluster spacecraft. This is absolutely normal because the cluster spacecraft have their own computerized sequence before they can start the flying phase. And perhaps ESOC, Philip, can tell us more about this sequence.
What about your ESOC? Can you give us some information about the cluster red status? Apparently that's not possible at the moment. So we're back here to the Jupiter Center with you, Juan and Pierre. The red status means that the stop came just before the automatic sequence. It would be a good idea if you could explain to us what the automatic sequence is, Pierre.
The automatic sequence is the final part of the countdown. Why do we call it automatic sequence? It's because it means a sequence of operations conducted fully automatically, and it is absolutely precise. What does it contain? There are the final operations to configure the launcher. The top-ups are finished off. You know that they continue permanently, but during the automatic sequence they are stopped. The pyro equipment is armed. The pressurization of tanks reaches flight level. The power supply is moved from ground to board. The deluge is triggered off. The water damping that is needed for noise attenuation during liftoff. And at the end of the sequence, the computers hand over to the onboard computers, which command the ignition of the Vulcan engine. Then, when the thrust has been established at nominal level, the command is given to the solid boosters for the launch vehicle to lift off.
We'll come back to that in a moment. At the moment, there's weather red status in Kourou. There's also red status for cluster. Mike McKay, can you explain?
I'm afraid I don't have any further information about the red on cluster. We have held at H-11 minutes on the spacecraft, as you may have already seen. We have let the countdown for Ariane 5 run to launch -7 minutes, which is the start of the automatic sequence. We've had it confirmed that all 4 spacecraft are on internal power, and more information on the red status, I'm afraid I don't have at the moment.
Can you give me any
I'll try to find some more and come back to you shortly.
to the likelihood of getting away at 12:05?
Juan, vous avez quelques informations à nous donner?
I think you've got some information to give us.
Perhaps we can, sorry, I was listening to the operations manager, excuse me. Perhaps we can explain how the cluster network works. We saw pictures of the cluster representative here in Jupiter, who is in close contact with his team at the launch center. And I tried to explain that the cluster launch sequence is also computerized and automatic, and it has to be, of course, ready to lift off at the same time as the launcher. Now, these two computerized sequences, if there is a hold in the countdown, have to be both reset so that they start simultaneously at -7. As soon as there is a red on one of the two sides, it has to be checked that both launcher and spacecraft are still synchronized to be able to continue. In case of hold during the final synchronized sequence, that is, supposing we would resume now at -7, then any red coming from any system summarized in the status panel, would automatically stop the countdown, and the operations manager would then reset the clock back to -7, so that the teams responsible for whatever system is not ready would take the time to check the source of the anomaly, to correct it, and if we are still within the 2 hours permitted launch window, then we would resume at -7 for a liftoff attempt.
On retourne à l'ESOC.
Back to ESOC. Mike McKay, have you any news for us?
Yes, I do, and I think it was also explained, also very well, I think, by Pierre, that the red we have is due to the count being held by the spacecraft at launch -11 minutes. It is not red on board the spacecraft that we have a problem that would stop the launch, and as soon as we would recycle back to launch -11 minutes to pick up the countdown, then we would again have a green on all 4 spacecraft. I've heard also reported here within the control room itself that all the ground system is still green, all the ground stations are still there. I see on the panel above me, there is not one yellow, not one piece of red. So from the ground system we're ready, the computers are still all green, the communications links, and all of the personnel here, as I say, a bit of excitement now with this slight postponement of the launch, but still everyone very well relaxed. They've rehearsed this procedure before, and we see no reason why we shouldn't go again in another half an hour's time. So I think we go back to Philippe in Jupiter 2.
Juan, on a entendu tout à l'heure les annonces faites par le
We
directeur
just
des
heard the
opérations,
announcements
Pierre Barbier.
made
Vous-même, vous
by
avez
the
effectué
range operations
ce
manager.
rôle
You
de directeur des
yourself
opérations. C'est l'occasion
were a
peut-être
range
d'évoquer
operations
tout ce qui se
manager,
passe
so perhaps you
dans
can
cette
tell us
salle de
exactly
contrôle
what happens
derrière,
in
où
the
reviennent
control
toutes
room
les
behind the
informations.
glass that collects all the
Il est en
information.
effet là le point de tout ce qui concourt à la réussite, toutes les informations
They
nécessaires
have
à la
all
réussite
the
de
data
cette
that
mission.
contributes to the success
À la
of
fois le
this
côté
mission,
vol,
both
à
for
la
the
fois
flight
le côté
itself
centre, de
and
lancement,
also
et
the
puis à la
data
mission également
concerning
cluster.
the launch center as well as
Certainly,
the cluster
I
data.
think we have not talked yet about a very important mission of the Space Center here, which is safety. This is split in 2 main missions, ground safety, that everybody can understand, protecting people, protecting the environment from any hazardous operation, but also the other side of safety is flight safety. In fact, during countdown, the flight safety team sitting in a nearby building, in fact in the old Jupiter building, monitors the links between the launcher and the flight safety facilities to make sure that dialogue via radio link is permanent. And this is needed after liftoff. The flight safety team monitors permanently the trajectory of the launcher and can send the destruction command in case of a very abnormal trajectory so that any overflown area is protected. And this was part of our task when we were in the operations team here. Safety is number 1.
Pierre, vous avez
Yeah.
réussi à avoir quelques
I
informations
think you've
nouvelles.
succeeded in having some fresh information, haven't you?
Oui, alors la situation météo
The weather situation
est suivante.
is the following,
D'ici
apparently.
une demi-heure, nous devrions
In
pouvoir
half an hour's
lever
time, we ought to be able to lift the C2 criteria, the lightning risk in altitude. As I've just said, it's probably in 30 minutes from now. As to visibility, it's not so sure. However, we do have a camera at our Montabo station in Cayenne, which in half an hour to an hour's time could possibly
la séparation des EAP à 60
visualize the solid booster separation at 60 kilometers altitude. That's all I can say for the moment.
À l'intérieur de cette météo, finalement,
So
il y a deux
within
aspects.
the weather
et
conditions, in
pour
fact, there
un
are 2
des aspects,
different
la
things,
forme, on
and
considère
for
que
lightning,
probablement d'ici
you
une
consider
demi-heure,
that probably in half an
le
hour's time
interdit
it will
devrait
be
être levé.
possible to
Juan,
lift
c'est
the
quand même
ban.
important
Juan,
d'expliquer tout
I
ce
think
que
it's
font
important
les-
perhaps to explain
les
exactly what
responsables qui se
is
trouvent à
done by the
l'intérieur de
people
ce
who are
centre de contrôle.
within this control center.
Yes, I think we are only seeing the tip of the iceberg here. we were saying that the operations manager has different deputies. Each of them is in contact with his or her own team in a different location. And again, this is only part of the very large Ariane and satellite family, involving today more than 10,000 people throughout Europe. The range operations manager is the one we see at the moment of the launch, but he is but one member of this large Ariane family. And a particularity of our family is that we have this so-called Ariane spirit, where despite the fact that people come from different countries and speak different languages, as Jacques Durand was saying, we are not Tower of Babel. We do apply the same quality assurance methodology and philosophy, and there is a great technical transparency between the teams, between the different industrial companies. This allows us to have each single member of the Ariane family fully play the role independently of the size or of the nationality of its institution.
What I propose now, since the weather red signal is still there, is now to see some shots that illustrate some of the particular aspects of the Guyana environment, because it's an advantage being near the equator. It means you can obtain a slingshot effect by using the increased rotation speed of the Earth. However, at the same time, there's a climate that's more difficult to determine in advance, and we'll see some footage that shows how the forecasts are made here in Guyana.
The weather criteria are either red or green. We mustn't have a lightning risk in a 10 kilometers radius. The other two criteria are linked with the type of clouds around the launch pad. It's the type of clouds and the thickness of the clouds that could lead to lightning establishing during the launch vehicle's flight. But we also have wind criteria. What you see here are electrical discharges which can either occur between the clouds or between Earth and the clouds. Every little line here, every light corresponds to a lightning. Guyana is under the influence of a northeast. The cumulus will come in here. We have simulation of Meteosat 3 in the infrared channel. We see here the evolution of the famous convergence zone, and this is a medium-term forecast, 24-36 hours. This gives us a better idea of what is actually happening in reality.
It's even more difficult to determine this climate situation in Guyana because we're in a zone where the cloud cover is very complex.
Yes, the Guyana is under the influence of the intertropical convergence zone. It is characterized by two pressure centers with a low pressure center between the two high pressure centers. This is very unstable, and it's something that occurs very often at this time of the year. This unstable situation is impossible to foresee, and this is unfortunately what's happening this morning.
There's another aspect, and that is the accuracy of the weather forecast depends on the network of observation stations. And since there's the ocean, there aren't as many stations as you would have in Europe, where you have very refined forecasts.
This is correct, Philip. You know that in higher latitudes we are quite precise in the weather forecasts because mathematical models have been developed, and meteorologists can just use these computer programs to fit in their observation data coming from ground instruments or even from meteo satellites. The difficulty here in the tropics is that weather changes much more rapidly, and the mathematical models developed for higher latitudes unfortunately do not give us enough reliable information.
On va aller avec vous, Juan, puisque à un certain moment
To
vous
you,
étiez de l'autre
Juan,
côté de la vitre.
because at one point you were on the other side of the glass when you were range operations manager. And now with a camera we're going to monitor what's happening and see how data is received here in this center, all the data that contributes to the success of the launch.
Yes, this new Jupiter building is in fact split in two main parts. Where we're sitting is the VIP visitors part, and the camera is right now on the mission control half of the building. The different deputies to the operations manager involve logistics, optical systems. These people here are in touch with the telescope operators on Devil's Island and on Montabo Hill in Cayenne. The telecommunications team has the so-called Mercure building nearby, which is the node point managing all the telecom links with the sites, the downrange stations. Here the tracking people use radar on two different hills in French Guiana to track the first part of the trajectory for the benefit of flight safety. We have talked about telemetry and its important mission, which is to receive on the ground and record all the data, more than 100 parameters during the flight. Some of the managers in Jupiter seem not to be too much concerned. Maybe it means we might have a green.
Derrière nous, dans cette salle, dans ce CDC, se trouvent trois
in the
des
center,
quatre hommes
there are
clés
three
auxquels nous
of the
avons consacré un
four
sujet,
key
car bien évidemment,
figures
ce n'est pas
that we're
pendant la
going
journée
to
du
see
lancement
now,
que nous
because it's
pouvions
not
aller
during
leur
the
demander de
launch
livrer
day
leurs
that we can
impressions.
go and ask them then for an interview.
It's quite an adventure. If I speak of those who started the program, I think we ought to remember the 80s, when the teams in France started working on the Vulcan engine that equips the central stage. A few years later, Germany and Sweden joined, and the European Space Agency made up a Ariane 5 preparatory program. For some, this program is 15 years old. CSG is used to launching Ariane 4s at a rate of 3 weeks or a month, now has a new challenge to pick up. It's a new launcher, it's a new launch vehicle, new technology, a new launch complex, and few know that the Guyana Space Center is also quite new. The CSG, who had a routine habit of Ariane 4s, needed more performant facilities, more qualified to the launch vehicle, more adapted to the launch vehicle, and all the staff had to be qualified. We needed 6 months for that. This is something that is not at all routine, and everything that is not routine is interesting, especially for our work. And we have many surprises. During this campaign, which started 3 months ago, it's been long, it's been arduous, but what we can say is that it took place in a satisfactory manner, thanks to the competence and the courage of all those involved. You don't do this job if you're not 150% motivated. All those who do this job cannot do it half-heartedly. All those who participate in the launch of Ariane 5 are people who are totally committed. You can't do half a job. Every time we start a campaign, we are totally committed. Thanks to this motivation, we can do something, we can do a good job. It's present everywhere. It's always interesting to work on a first event, on a first launch. We need to find our settings. We make new discoveries. We have to solve problems. Some people call us space nuts, but I don't think that's quite correct. We're very enthusiastic, and we want things to come to conclusion.
And again, see Ariane 5 on the launch pad, ready to lift off as soon as the two red status signals have gone, especially the red weather signal. Pierre, could you give us some information about the Ariane 5 launcher that has nothing to do with its big sister, Ariane 4?
Ariane 5, as you said, Philippe, is a quite different launch vehicle in comparison with Ariane 4. We've said this before. We could perhaps specify and give you some figures. Ariane 5 has a height of 53 meters. This height can also vary according to the fairing. Today, we have the configuration with a dual launch configuration with the Spectra bearing structure for the two lower clusters and the so-called short fairing for the two upper cluster satellites. With this configuration, the height is about 53 meters. The diameter is 5 meters 40, which for the fairing is significant. The Ariane 4 fairing is 4 meters in diameter. The lateral boosters have a diameter of 3 meters for a height of 25 meters. The launch vehicle, in total, on its table and filled with propellant, has a mass of 740 tons and thrust at liftoff close to 1,200 tons, 2 times 600 tons for the solid boosters and about 100 for the Vulcan engine of the central stage. 1,200 tons with a thrust with a mass of 740 tons. The acceleration of the launch vehicle is considerable, and you will see that at liftoff. The launcher will have a very considerable thrust at liftoff.
And now we're going to be going back to Toucan, where we'll find Martin Ransom, who has with him one of the guests who can give us some additional information.
Yes, we're coming back to the weather aspect. And we have somebody here who knows this problem very well. We have Mr. Hubert Palmieri with us. He's a veteran of Ariane operations. He's been following Ariane operations since the very first launches. Have you very often seen weather stop the countdowns? No, not often, but it has occurred with criteria that are not always the same as today, as it wasn't indispensable for an operational launch to have full visibility of the trajectory over such a long distance. But for lightning criteria, or for a lack of visibility for safety reasons in the first launch moments, has hardly occurred. Some moments ago, you were explaining to other guests, you were showing, pointing to the skies. What do you think about the skies? I think we have to look in certain directions. Well, today things are terribly complicated. We have hardly any wind, and we're in a barometric position that hardly allows for a quick evolution, neither in one sense nor in the other. I admit that I'm not very enthusiastic, I'm not very optimistic, but perhaps the sun will change things, perhaps the sun will bring us the necessary clearings. And I have the experience of some weeks ago, V86, Ariane 4, we had a very short launch window, and we had 30 minutes countdown hold. 5 minutes before the end of the window, we got the clearing that allowed for liftoff. But that clearing was necessary because of lightning risks. The clouds that provoke lightning during flight are easier to predict, and that's what was said here earlier, was announced. But to get rid of all the clouds here, to get perfect visibility with weather like today, that's quite a big problem. We would feel like blowing like the Three Little Pigs. If we all blow in the right direction, maybe that would help. Thank you. That was the weather problems concerning the Ariane launches.
Thank you, Martin. You've given us some hope because it's already happened once. In fact, 5 minutes difference, it then became possible. We are back to Mike McKay, who's in ESOC at the moment.
Yes, I'm here with Paolo Ferri, who's the spacecraft operations manager. Here it's been relatively quiet. We haven't had that much to do. But Paolo, this isn't the first launch hold that you've seen, is it?
No, actually, we've done this several times during previous simulations. There's a long simulations campaign that goes through the last few months before every mission. And in fact, we had a launch hold also in the dress rehearsal that we had last week. So we've gone through this several times.
What actually happens when you have a launch hold as regards the spacecraft?
Well, on the spacecraft side, there is in 4 minutes activities that need to be redone in case the launch is held at 7 minutes. And these are activities like the resynchronization of the onboard time. We reset it to 0 in order to synchronize all spacecraft also with the ground segment. And we reset some onboard buffers that we need to have empty when we get the first acquisition of signal with the spacecraft. And the final important thing is that the automatic separation sequence is started in these last 4 minutes. This is all done by the launch control center, but at ESOC we can see the telemetry on one of the 4 spacecraft, and we can monitor this.
So currently we have green on all of the spacecraft, and when we resume the countdown we should see the 2 reds going back to green. Is that correct?
That's affirmative. It will be like this, and what will happen is that the launch countdown from 7 minutes will go back to 11 minutes.
So now we just have to wait on the good weather from Kourou. And you also have simulation for, what, 3 months before?
Actually, we started 6 months before.
Okay.
And this is, for such a complex mission, is absolutely necessary. We had a large number of simulations. And in particular, we simulate a lot of possible contingency cases. So we've gone through all sort of scenarios from the nominal to the contingency and back to the nominal in the last few days.
It must be quite a challenge actually flying 4 spacecraft. I mean, I had the opportunity of flying 1, that was difficult enough. Is there anything special in these contingencies that you have to watch with for 4 spacecraft?
Yes, one of the very special thing, I mean, you've been in the same position as I am for 1 spacecraft. One of the very difficult things is that you have to continue with the nominal operations while the contingency operations are ongoing with one of the 4, the one which is experiencing problems. And this is quite a different way of working from what we're used to with a single spacecraft, where everything can be concentrated on the failed spacecraft.
I can see here that we have a full main control room. Sitting behind me in the front row is your flight control team. It must be important that we have so many people to control the 4 spacecraft, and also the level of competence that you've managed to generate over the last 3 months of training. How has that actually developed?
We built up a control team 3 to 2 years before launch, and we started in this case with already experienced people, although they're all young, but most of them have gone through a mission before. And we go through a long period in which we actually develop the flight control procedures, and this in parallel helps us in developing experience on the mission and on the spacecraft and knowledge on the spacecraft. But again, the key point of all our preparation is the training and simulation campaign that takes place in the last 6 months. And in particular, during this campaign, we actually tune not only the procedures, but also all the activities that have to be executed in parallel between so many people. This is the most crucial thing for a mission like this, where so many flight controllers work in parallel.
Yeah, I've actually watched the team go through the simulations, and over the period of time, you see not just the team here, but the team that sits in the background that you don't see, the people who operate the computers, the people who make sure the data flows into our system, has really come together and worked as one real integrated team, and that is really the key to the mission success that I think we have here. Would you agree?
Yes, absolutely. Integration is the real key word for this mission. It's not only integration of 4 spacecraft teams together, it's also integration of 7 ground stations. It's a very complex ground network. The network control people have an extremely difficult task, in particular in these first few hours of the mission. And we all have to synchronize our activities together.
Okay. Well, I think we'll keep our fingers crossed that we don't have to exercise any of the contingencies that you and your team have had to go through in the last 3 months. At the moment, we only have a green on the Meteo, and I think we'll have to go back to Kourou to get another update on that. So, Paula, I wish you and all your team a very successful launch of all 4 spacecraft and a good injection into orbit. Thank you very much. So I think we go back to Jupiter 2 and we get an update on the Meteo situation there.
Here, not only are we crossing our fingers, but we're fortunate to be able to touch wood, and that brings you luck apparently in this studio. You shouldn't run away with the impression that only men are involved in this space venture in Europe. There are also women working here at the CSG, and now we're going to see exactly what these women do and what their duties are.
You're here in the booster integration building of the Ariane 5 launcher. This building is an industrial building built specifically for that purpose. Here, the stages are assembled. On the Guyana Space Center, you see the various stages that make up a booster, and it's our role to assemble them, integrate them. We integrate the engine, the 3 segments, and the nozzle, and then the individual stage elements, the forward skirt, the rear skirt, and the electrical, hydraulic, and pyrotechnical equipment that allows for the stage to ensure the functions that are necessary: flight control, guidance, and distancing after the stage has functioned. Within this building, we perform integration and test activities. Tests took place on the solid booster test stand. The integration activities and checkout operations are all carried out here, and their acceptance tested. They are made available to CNES to put the launch vehicle together. Originally, I was quite passionate about aeronautics, and I started working in the space sector. I started in the pyrotechnical area, basically because there were not many women around, but I felt very well, and I had excellent team work that I experienced there. I learned a lot. And when I moved to the solid booster activities on Ariane 5, I must admit that I never ran into great difficulties in my job.
How long can the launcher wait on its launch pad, Pierre?
There's no problem for the present launch window. The launch vehicle can stay there as long as nothing happens on board. As long as everything goes well, it can stay out there for a day or 2.
What happens on the launcher during this period when it's waiting there?
What happens during this waiting period? While we're in the launch window, the launch vehicle is waiting for the automatic sequence. We carry out top-ups as hydrogen and oxygen are extremely volatile. They're at very low temperatures, they evaporate constantly, and therefore we have to top up constantly in order to keep the levels at the right figures. Furthermore, we check out all other important parameters representing the state of the launcher. If we were to run beyond the launch window, we'd have to drain off the liquid hydrogen and oxygen.
Is there still a red status for the weather?
Still red status, but we can see on some of the pictures being sent to us that there's a somewhat clear sky coming from the sea, and that's where the weather comes from with the trade winds. The status panel shows nevertheless 2 red, and I would like to explain clearly that even though the cluster is showing red, it does not mean there is a problem whatsoever on the 4 spacecraft themselves or on the ground network of cluster control stations around the world. This red color is just shown to make sure that as soon as the countdown resumes at -7, it will be simultaneously the running down of the computerized sequence for cluster. We want to make sure that everyone works in a synchronized manner here.
As you said, the first mission of Ariane is to carry 4 cluster spacecraft that will give us some insight into the interactions that exist between the Sun and the Earth. So perhaps now, with some very nice pictures, we can see exactly what this cluster mission should be.
To casual eyes, the familiar Sun seems calm, even deadpan, but its atmosphere is hot and stormy. The Sun's visible surface is agitated and racked by explosions, and non-stop streams of charged atomic particles race outwards in the solar wind. Far away, the Sun's rays bring life to the planet Earth and drive its weather. But a different kind of weather comes with the solar wind. Auroras glow when solar particles hit the air around the Earth's magnetic poles. To find out exactly how the solar wind affects our planet is the task of the cluster mission. Many previous spacecraft have probed the streams of particles that dance like invisible auroras all around the Earth. Cluster is unique in operating 4 satellites together. Why 4? The ever-changing patterns of activity recorded by a single spacecraft leave scientists perplexed about what's happening. A pair of satellites can start to make sense of changes in activity. For a rough impression across a slice of space, 3 would do. But to see the particle streams and fields clearly in 3 dimensions, you need 4 satellites. When the solar wind reaches our neighborhood, the Earth's magnetic field prevents most of the solar particles from reaching our planet. But some break through the magnetic defenses. Cluster will tour the battlefields where magnetism and the solar wind fight for control of the Earth's surroundings.
À tous les vidéos pour information sur la chronologie, les conditions météorologiques semblent s'améliorer. Dans 15 minutes à partir de maintenant, la décision sera prise de poursuivre la chronologie ou non. Tous les moyens se tiennent prêts dans la configuration, moins 7 minutes n'ont passé.
The problem of preparing 4 identical spacecraft. This required virtually a production line with different teams working in parallel. Every one of the 4 spacecraft is essential for the mission's success, so the construction was like giving birth to quadruplets, and each cluster spacecraft, like a baby, required 100% care to make it fit for a mission in space lasting at least 2 years. Cluster's orbit will enable the 4 satellites to explore the cavern in space created by the Earth's magnetism. Examining their signals, Cluster scientists will look for the entry points where particles from the Sun infiltrate through the magnetic shield. Do they break in through the front door? And do they come in stealthily or in a rush? Apparently some of the solar particles slip round to the back door and then blast their way in. How do they manage that? Others battle for admission at weak points in the shield over the Earth's magnetic poles. It's an electrical puzzle laid out across thousands of kilometers of space, and each satellite in the cluster is a state-of-the-art electrical laboratory. All the cluster satellites carry the same instruments. Working as a team, They should answer questions about the Earth's space environment that have baffled scientists for many years.
When we were off in space with the 4 cluster spacecraft, an announcement was made by the range operations manager.
This is correct, Philippe. He was explaining that every system, everybody should be ready and on standby for a possible decision to resume countdown in about 15 minutes. There seems to be a clear sky window within the large window in 20 minutes from now.
Roger Maurice Bonnet, you're the director of the science programs of ESA. For this first mission of Ariane 5, there is a scientific payload, and I think this is a good opportunity to see with you to what extent Ariane 5 is going to be involved in the scientific work.
For us, Ariane 5 is the workhorse for the European scientific program. Most of the missions we intend to launch in the coming years into the next millennium will be basically using this high-performance launch vehicle. We know also that it's very reliable, and we know that we have a dozen missions in front of us. They will basically be using Ariane 5.
Without going into too much detail concerning the 10 missions you've mentioned, can you tell us in what areas you're trying to obtain greater insight?
You will be having, for space science, the possibility of going beyond the atmosphere to send out telescopes that have very high-power satellites with Ariane 4. Last November, we launched ISO, the equivalent of ISO for X-astronomy. We're going to use X-rays to track the skies. That will be the XMM mission. In 2006, 2007, a few years later, we'll have another infrared telescope that is even larger than ISO. It's called FIRST, a space telescope that will also use Ariane 5's launch vehicle. In the field of planetary exploration, Ariane 5 helps us with its unique capacities, and for this purpose, we have envisaged to launch in 2003 a mission to a comet that will analyze the pristine material of comet. Produced by NASA, one by Europe, and it will study the evolution of the Virtanen comet, thanks to Ariane 5.
Thank you, but that's for the years to come and even for the next millennium. But closer to us, we have Martin Ransom, who's up there at Toucan with a guest.
Oui, Philippe, peut-être on peut utiliser cette occasion.
Perhaps we can take these few minutes before we return to a countdown, which we might get in a quarter of an hour's time, to talk about the ground facilities. The launch vehicle is the main vehicle, but the enormous effort of engineering carried out here on the Kourou site were considerable. The design of the launch base was quite different from the design that had been adopted for the second launch pad, the one that is still being used for Ariane 4. Mr. Pierre Perez, can you tell us about the design specifications that were adopted for Ariane 5? The main difference between LR3 and LR2 reside in the design of the launch zone, the launch pad itself. We wanted to have a very simple launch pad so that in the case of an accident, the refurbishing of the launch zone would be as easy as possible. We set ourselves 6 months to refurbish a destroyed launch pad. Therefore, we have a building that is for the launcher preparation, the final assembly building on the LR3, and the final assembly buildings. We carry out the operations that are carried out on the LR2 launch zone under gantry. Here we do this in the BAF. We also fill the storable propellants there. In the launch zone, we only carry out cryogenic operations. We fill the cryogenic stage. And on the LR3, we don't need this gantry. We have on the launch table on LR3, all the equipment necessary to fill and pressurize the tanks, whereas on the LR2, the equipment is in a tower next to the launch table. You were also able to see that a second table is under construction. In the case of an incident, if the table were to be destroyed, we would have a backup immediately to start up very quickly with a new launch campaign. This is as far as design goes, but perhaps we should illustrate the work undertaken as far as engineering goes. Very few people realize that the test bench for the solid boosters, this enormous flame trench required hewing out of the granite more than 500,000 cubic meters. This was a pharaonic task. Yes, we had a huge flame trench hewn out of the granite rock in order to be able to test the solid boosters in vertical position. Thank you, Mr. Perez. And back to Jupiter for more news on the countdown resumption.
Yes, indeed. At the beginning of the video broadcast, I explained what's meant by a launch window. It starts at a certain time and there's a certain duration for the mission, and the slot depends on the satellite mission as well as on the launcher itself. What are the parameters that determine this window with regard to the mission, that is, one?
Well, the launch window determined by the spacecraft, by the cluster satellites, depends very much on the operations that have to be performed on the spacecraft after they're separated from the launcher at the end of the launch. In fact, the teams on the ground control stations want to know very quickly what the attitude, that is, what's the relative position of the spacecraft once they are flying independently from the launcher in orbit. Because if we don't know this exact attitude, we will not be able to command the firing of the satellite engines for the final positioning. So in order to know very quickly the attitude of the spacecraft, the onboard sensors have to be able to see the sun, to see the moon, to see the Earth at a specific angle. And this is only possible at certain times of the day or of the night. And at the same time, also another constraint is that onboard satellite batteries have to start getting charged not too late. So also the visibility from the sun is important once the satellites are flying independently.
To charge the solar panels, they have to be facing the sun so that the solar energy can be converted into electrical energy. And now we're going to have a link with Mike McKay, who's in ESOC. Mike.
Hello. Well, we've had some update on the status at the moment. We actually switched all four spacecraft onto their internal power, so they're running off batteries. That occurred over 1 hour ago. And we've been monitoring the telemetry. Unfortunately, we can only monitor one spacecraft, so it gives us an indication of how the other three are actually performing. And I've heard the systems engineer just report on the voice loops that the nominal consumption has been performed. We don't foresee any problems. That spacecraft is green, and we have no reason why we should actually declare anything red on the spacecraft side. I've also heard that all of the ground stations, all of the computer networks are still green. I see just on the board we have no sign of yellow or red. So we're still ready to support, and we're looking forward to getting the countdown started again. I have heard that the weather has 3 conditions to be met. 2 have already been met and are green, and we're just waiting for clarification. I believe that the separation of the boosters and the visibility of that is actually green for launch. So I don't know if you have any further update back in Jupiter 2 on that.
Mike has just told us one of the reasons why the visibility must be good is because we want to be able to monitor what happens when the 2 boosters separate from the vehicle, from the main cryogenic stage. Why is it necessary to monitor this operation, Pierre?
The general outlay, the general layout of the launch vehicle, is based around a central stage and the 2 lateral boosters. We want to observe the separation of these 2 boosters when they have burnt out. They're enormous stages at the end of propulsion. A booster still has a mass of 40 tons. It's very important to realize under which conditions these large stages separate from the core stage. The separation takes place by cutting the struts that connect the boosters with the core stage, and the ball and socket joints are the top connection. There are distancing thrusters that allow for distancing of the boosters, and we want to observe this separation. It's also important to be able to follow the movement within the boosters. The boosters are going to be recovered with parachutes at sea before the parachutes open. The movement of the boosters interests us. This is why we want to have as much visibility as possible of this phase.
Yeah, we have some direct shots from a helicopter that show us, well, the ceiling, as it were. So what's the result of these requirements, and what happens with this meteo green signal?
Yes, Philip, as we were saying, clear sky is coming from the ocean, and all systems, everybody here is getting ready for resuming countdown in a few minutes only. We should see shortly both cluster and meteo status becoming green, and then the operations manager announcing beginning of synchronized sequence.
Here you can see Ariane 5 on its launch pad, and you can see, Juan, a horizontal blue stroke that seems to indicate that things will improve.
Yes, and the visibility should then be enough for separation, to see the separation from the telescopes. The weather in French Guiana, when you want to know what will happen in 10 or 15 minutes time, we always look to the sea. We don't look to the mountains, to the mainland, because it's from the sea that the clouds are coming, with the pushed by the trade winds.
Well, I referred to this little bit of blue sky. There is, as I said, real clearing appearing. But we have to see whether this is going to be enough to allow this visibility that's absolutely necessary in this case. Pierre, what's the weight of these 2 boosters? Once they finish the combustion process, what's the weight of the structure?
The solid boosters are made up of a steel case where the grain is charged into. At the one end, there is the igniter, and at the other end, you have the nozzle that ejects the gases of burnt grain. At the top, you have the cone-shaped tip. You have the separation system on it, and you also have the attachment system. The rear skirt that envelops the nozzle, holds the booster to the central core, and the whole launcher sits on these boosters.
À tous les DO, nous avons un vert météo. Le satellite cluster engage les opérations de programmation du séquenceur. Au retour au vert du satellite cluster, nous reprendrons le décompte.
That's a very interesting announcement that's being made by Pierre Lebarbier.
Yes, you can imagine that I was listening to his internal conference before he made the announcement. Of course, we are authorized to do this. And it's just now a matter of very short time to allow for the cluster people who are sitting at only 3 kilometers from the launcher and from their 4 spacecraft in the launch center to restart their sequencing programmation. And as soon as they show green, then we hope Meteo will still be green and we can resume countdown. The telescope on Devil's Island is sending these somewhat gray pictures, but as was said, there is another telescope on a small hill close to Cayenne, about 60 kilometers from here, and that telescope seems to be seeing clearer skies. I hope we can see the high performance of this automatic tracking telescope during the flight.
Let's come back to a point you mentioned just before the important announcement of the operations manager. We were talking about what happens to the boosters, the fact that their mass is very considerable, and the fact that when they splash down, they're operated by parachutes.
The 2 boosters can be recovered. It's not an obligation. We're not going to do it systematically for every flight. Today, we have a qualification launcher on the pad. We want to qualify as many systems as possible, among others, recovery of the boosters. The system is made up of a parachute loop. For a certain time, the stage falls back like a stone, and then a small parachute, a drogue parachute, opens. It breaks it down the speed, and then an extractor system functions to open up the large canopy, which has a surface of 1,800 square meters, and it falls back at 90 kilometers per hour. The recovery vessel left the day before yesterday, and this vessel will try to recover the 2 solid boosters.
You can see Ariane 5 again on the launch pad. There's a little bit of mist here. And here you have a helicopter view. How would you analyze it from here, Juan? We're not asking you to say if this is going to be
It's
confirmed.
a great pleasure for me to be sitting here in the dry and see what I'm used to see when I fly with a small airplane here.
Nous avons un vert de tous les moyens. Attention pour reprise du décompte. Top. À tous de l'EDO, le décompte est repris. Nouveau H0 visé. 12 heures, 33 minutes, 59 secondes, temps universel.
Juan, on voit à nouveau le décompte.
Once again, we've resumed the countdown. We're now at 6 minutes 37 from the liftoff. So we're now into the automatic sequence.
Yes, this is correct. We are within the synchronized sequence now. And very soon the operations manager will switch to automatic status transmission. This means that any red, any problem occurring in any of the systems during this sequence would automatically bring the countdown to a hold. This is done because there are such a great number of checks and commands being sent to the vehicle that manually one could not perform this with enough reliability. Still, though, there is a separate system of manual interruption of the countdown. This means that the human beings can still override the computers in case of a major problem.
The red status meant that there had to be held before the final sequence. What happens if there's another cloud and there's another red status
Well,
signal?
the meteo status is not included in the automatic transmission because this sequence is only started if the weather forecast guarantees the respect of the three criteria for a period of time which is long enough to cover for the whole synchronized sequence. So there is no short notice meteo red to be expected.
Yeah. 4 minutes 40. And I think it's important to explain what's going to happen with the Vulcan engine in particular.
First of all, we're still in the preliminary phase of the automatic sequence. We're configuring the launch vehicle for the last and final phase when the launch vehicle is ready for ignition. At 4 minutes, we're going to pressurize the liquid oxygen tank of the central stage and then the hydrogen tank. Then at H- 1 minute, we move on to onboard power. Until then, the launch vehicle is powered by ground facilities, and then at minus 30 seconds, the deluge in the jet deflectors of the central stage and the boosters is started, and then flight control is started, the servo actuators that govern thrust vector control. At H0, 3 seconds before H0, ground hands over to onboard. It will be the onboard computer that commands startup of the engines and also commands liftoff. The engine is ignited and then it is checked out. The engine starts by opening a valve. The propellant enters the combustion chamber. At the same time, the gas generator is started up. That gives the turbines hot gas. It spins up the turbines and the pumps. And then the pressure establishes. And at 6.7 seconds after H0, we check out the chamber pressure. In that case, the onboard computer commands ignition of the boosters, and around 8 seconds after H0, they lift off.
It's important to mention this deviation between HO and the real liftoff of Ariane 5.
Yes. H0 corresponds to the opening of the feed valves of the Vulcan engine. Only 8 seconds later, we will see liftoff of the launch vehicle.
There's another piece of information I'd like to have, and that is the flight sequences, so that we know what's going to happen afterwards, because, of course, we're at minus 2 minutes, so we have to be very quick. A couple of figures.
There are 4 phases. The powered phase that brings you out of the atmosphere, that lasts 2 minutes. Second, the continuation of the flight with the EPC until 10 minutes. When all propellant is consumed, then the EPS is ignited, the storable propellant stage, and then the satellites are oriented. The flight will last about 30 minutes.
1 minute and 25 seconds. And you see people leaving the Jupiter Center to see this.
À tous de l'EDO. Attention pour H-1 minute. Top, moins 1 minute et des comptes.
Nous sommes à 56 secondes du premier vol d'Ariane 5 qui emporte.
We're about to see the liftoff of Ariane 5 that has on board 4 cluster spacecraft.
À tous de l'EDO, attention pour décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité, feu. Allumage. Décollage. Tous les paramètres propulsifs sont normaux et la trajectoire est normale. À tous de l'EDO, tous les moyens restent à leur poste.
Vous l'avez compris, c'est une immense déception.
You will have understood this is an enormous disappointment. Michel Mignot, who is director of the CSG, will now make an official announcement.
For as yet unknown reason, the launch vehicle exploded in flight 4,000 meters height after liftoff, and the fragments fell back in a zone that was protected. I can reassure you there is nobody in these protected areas. Links with all personnel and outside sites have been activated. The intervention plan will start up in a few moments. The prefect is in the emergency room, and I will go and join him when I finish this declaration. The teams are going on the site and will save all sites. The invited staff on the Toucan site are being evacuated in a safety zone that is foreseen for this purpose. Guests on the observation sites Kikiwe and Colibri have already left in the buses towards Sinamari to get away from the impact zone. They wouldn't have been implied in any case. The personnel of Karapa is invited to return to Kourou. They risk nothing. They can come back to Kourou calmly. When every risk is discarded, people remain in LR2 and LR3 on their post. You listen to RFO or listen to the CSG journal. You will be informed constantly. In 30 minutes, I will give you more information. I would like to reassure our guests and the population for unexplained reasons. The launch vehicle exploded, but there is no reason for our guests or the staff on the site to be worried about this.
Marie Luton, Director General of ESA.
I would like to speak on behalf of all that the first launch of Ariane 5 was not capable of validating this launch vehicle. It was our first test flight, an entirely new launch vehicle. Each element was tested on ground in the past years and months. It's an entirely new design. This launch vehicle uses engines that are 10 times more powerful than Ariane 4. Its electronic brain is 100 times more powerful than the one used on Ariane 4. Many qualifications, reviews, tests, flight tests took place in order to confirm the choices made. There is, however, no filter ensuring absolute guarantee. Only flight tests with real environmental conditions of the launch vehicle can demonstrate its capacity. A second test flight is foreseen in the development plan. This test is due in a few months from now. And before that, everything must be done to understand this failure and to contribute the modifications for this second test to be successful. An inquiry board will be established in the coming days. This inquiry board will have to submit a report before mid-July in order to establish the causes of the incident, in order to find the modifications necessary to avoid another incident. Ariane 5 is an important element of Europe in space. The determination and the solidarity of all political, technical, industrial authorities allow Ariane to be confirmed in its final success. It's on this.
We now have a link. Or we should, in a few moments, have a link with Paris, where we'll hear the reaction of the French Minister, François Fillon.
Voici qui apparaît sur nos écrans.
The first flight of Ariane 5 was an experimental flight. Jean-Marie Luton said so. It was a matter of testing in flight an entirely new launch vehicle. In the history of European space, in the history of space exploration, the first experimentations, the first flights often have been the victims of incidents. the inquiry board will tell us what the reasons for this incident are, but I must reassure all engineers and all technicians of ESA, CNES, the CSG and industry that we trust them entirely. We know exactly which risks we run with the first event. As Jean-Marie Luton just said, Ariane 5 is an important element of success of space in Europe. For us, it means the certainty to preserve our first place in the field of commercial launch. It also means the perspective to man rate launchings, and this represents the political determination of all European governments taking part in the Ariane program. We fully trust the program. We will now prepare the second qualification flight, having fully determined the causes of this incident in order to be able to find the appropriate remedies. On behalf of all the guests here, I would like to tell all our friends in the Guyana Space Center how much trust we set in them. We knew which risks we were running. We will do everything within our capability for the adventure of Europe in space to be on the success path.
C'est sur cette note qui a été donnée par le ministre
on this note that we've just heard in the statement of François Fillon that we can continue with the arrival here of Yvan Uliev, who's going to tell us what his impression was and how he analyzes this rather sad event, which nonetheless does leave the door open to success.
When the disappointment has gone by, we'll have to stand up again and continue. We have said this was an experimental flight. A second flight will take place in a few months from now once the inquiry board has given us their results of their investigations. We need courage, and as far as Belgium is concerned, as Minister for Space Policy, I renew my full trust in the engineers and all the staff concerned.
Well,
after these moments of disappointment, the teams will be collecting information and data and analyzing it in order to find a remedy for Ariane 502. The venture continues here in Kourou. There are people who are disappointed. I heard people sobbing, but this emotional phase is over, and we're going to get down to work again so that Europe can lift off again in the third millennium.